Paper 1, question 3a. To solve this question, you need to apply the first law of indices. That is, when two terms have the same base and you multiply the two terms, you can add the power. Okay, so 7, the power would be x plus negative 3 will be equal to 7 to the power of 5. You can cancel away the base on both sides of the equation because they are both the same base. That leaves you with x plus minus 3 equals to 5. The plus times the minus, you will get minus 3 equals to 5. Bring the negative 3 over to the right hand side and you'll get positive 3. So x is equal to 8. In 3 part B, we need to find the perimeter of a square plot of land. We are given that this square plot of land, the area is 0.000188 kilometers square. Because we do not know the dimension of the square plot, we will just let it be x and x. Since the area is 0.000188, so we can form the equation x times x, which will give you x squared, is 0.000188 kilometers square. So x will be square root of 0.000188, which will give us 0.013711. And we want to find the perimeter. Perimeter means it's a length that goes round the square, which means 4 times of x, which will be 4 times of 0.013711, and that will give us 0.054844 kilometers. And we need to bring it to standard form. That would be 5.4844 times 10 to the power minus 2 km. Remember to leave it in 3 SF, and that would be 5.48 times 10 to the power minus 2 km. Paper 1, question 5. This graph is misleading because the vertical axis does not start at 0. It misleads the reader to think that the number of crimes has dropped by about 2/3 from 2006 to 2016. In this question, your m is inversely proportional to the square of n, and m is 15 for a particular value of n. So let's find out k. It will be 15 n squared. Okay, this is A. Now n is increased by 200%. N is, we have a new n, which we'll call n1, which is the original n, and we increase by 200% of n. So your n1 would be n plus 200 out of 100 of n. So n1 would be n plus 2n. So your new n is actually 3n. Now we have to find the new value of m, which we shall call as m1, which is k over n squared. We know that your k is 15 n squared, and your new n is actually 3n. So your m1 would be 15n squared over 9n squared. You cancel out the n squared, and your m1 would be 5 over 3. Now for B, we are supposed to find the percentage decrease in m. So originally we had 15 for m. Take away the new m over the original m times 100%, and you would get 88.9%.
In this question, you are given two bottles which are geometrically similar. The base radius of the small bottle is 4 cm and has a capacity of 300 ml. So for small bottle, let Rs be the base area, which is equals 4 cm. Capacity also refers to the volume of small bottle, which is 300 ml. Base radius of the big bottle is 5 cm, hence Rb is 5. Height of the big bottle, let it be Hb, equals 10 cm. Before we proceed, let's look at what we know about similar figures and solids. In general, for similar figures or solids, the linear ratio is constant, meaning to say L1 over L2 is a constant value. Area ratio would then be equals to the square of L1 over L2. Volume ratio is the cube of L1 over L2. In part A, we are required to find the height of the small bottle. Now, height as HS over HB is a linear ratio. Similarly, radius of the small bottle over the radius of the big bottle is also a linear ratio. Hence, these two ratios are equal because the bottles are geometrically similar to one another. HS over 10 equals to 4 over 5. We substitute the known values for HB, RS, and RB. So HS, the height of the small bottle, is equals to 8 cm. In part B, we want to find the capacity of the big bottle. Capacity also refers to volume. So we make use of the volume ratio, which is RB over RS cubed. We are given volume of the small bottle, which is 300 ml. So we substitute the value for the volume of small bottle, radius of big bottle, radius of small bottle. So V but B, which is the volume of the big bottle, is 300 times the cube of 5 over 4. So using your calculator, VB is therefore 585.9375 ml. Now we are required to express the value to 3SF. Hence, 9 here is more than 5. So the volume of the big bottle is 586 milliliters, correct to 3SF, which means capacity of the big bottle is 586 ml. In this question, we are given the box and whisker diagram for the science test marks of a class. Let's interpret the box and whisker diagram. This end of the whisker represents 25 marks, meaning the minimum mark scored by the student is 25 marks. This other n represents the maximum mark scored by the student, which is 85 marks. This end of the box represents Q1, the lower quartile, which means 25% of the students scored 45 marks or less. Q2 is the median mark, which means 50% of the students scored 65 marks or less. This side of the box represents Q3, the upper quartile, which means 75% of the students scored 75 marks or less. We are given that there are 40 students in the class. This means 100% of the student equals 40 students. Question is, how many students are there who score 65 marks or less in the test? Looking back at the box and whisker diagram, 65 marks corresponds to the median mark. So this means that 50% of the students scored 65 marks or less. 50% of 40 students would mean 20 students scored 65 marks or less. Now in B, the teacher moderates the marks by adding X marks to the score to every student, and the adjusted new mark is 100 marks. So this means that 85 marks here is now increased to 100 marks. Hence, X is equals to 100 minus 85, which is 15 marks. Part 2, explain how the median mark and interquartile range of the marks have been affected by the moderation. Now, the median mark original value is 65 marks or less. Hence, with X marks being added, that is 15 marks being added, the median will increase by 15 marks. While interquartile range remains unchanged. Why? Now, interquartile range is defined as Q3 minus Q1. New interquartile range is therefore Q3 plus 15, the new upper quartile, minus Q1 plus 15, which is the new lower quartile. Hence, new interquartile range is equal to Q3 minus Q1, which means new interquartile range remains unchanged. So we come to the end of the question. In this question, 3 regular pentagons are given as shown in the diagram. Before we proceed, let's visit some key points. Interior angle of a regular polygon of n sides is equals to n minus 2 times 180 over n. We also note that a regular pentagon has 5 equal sides. Let's look at this pentagon, regular pentagon. Each side is equal to one another. There are also 5 equal interior angles. In part A, we want to find the value of M, which is an interior angle of the pentagon. Using the formula, interior angle equals to n minus 2 times 180 over n, and substitute think n equals to 5 for a pentagon, m is equals to 3 times 180 over 5, which is 108. We also note that m1 equals to m2 equals to m equals to m3 equals to m4, and each of these are interior angles of the regular pentagon equals to 108. Looking at this part of the diagram, n plus m1 plus m2 equals to 360 degrees because they are angles at a point. Hence, we have n equals 360 minus 2 times 108, which is 144. So n equals 144. Now, we note that n is also equals to n1, which is angle ABC. So n1 is 144. P is the base angle of an isosceles triangle ABC. AB equals to BC, being the sides of a regular pentagon. So P equals 180 minus 144 divided by 2, which is 18. Now in part D, we are told that additional pentagons, regular pentagons, are added to form a closed ring. In other words, the closed ring forms another regular polygon of n sides. So let n pentagons form this closed ring, which is the new regular polygon with n sides. And each interior angle of this new polygon is 144 degrees. Applying the formula again for interior angle, we have interior angle equals n minus 2 times 180 over n. The interior angle is 144, hence 144n equals n minus 2 times 180. So that works out for 36n equals 360, hence n is 10. Thus, the number of additional pentagons required equals 10 minus the initial 3 pentagons, which is 7 pentagons. So we've come to the end of the question.
Okay, hi
Goodbye.
everyone, this is question number 18. Okay, for A part 1, you want to find in terms of theta the length of PQ. Okay, so how can you use the information that's already given to you in the diagram to find the length of PQ? Okay, so what you can do is to try to form right angle triangles. Okay, so over here, let me just put this point here as X. So I can see from my diagram that PQ, okay, and XR, they're actually the same length. Okay, and if you look clearly, okay, this OXR actually forms a right angle triangle. Okay, so if you want to find the length of PQ, it is actually the same as the length of XR. So how do you find the length of XR? You have a right angle triangle. Okay, you are given a reference angle theta. Okay, so this is the opposite side, the hypotenuse side, and then you have the adjacent side, OX. Okay, so PQ is the opposite side, so I will make use of sine. Okay, sine theta. Okay, the opposite side XR over the hypotenuse, which is 6. Okay, so XR is, okay, multiply over 6 sine theta. Okay, in other words, the length of PQ is also 6 sine theta. Alright, okay, part 2, find the, show that the height of the step QR, okay, so I have the step QR here, okay, is equals to 6 open bracket 1 minus cosine theta, okay, centimeters. So making use of the same right angle triangle. Okay, I know that this is the, okay, OP here is the radius of the circle, which means this is also 6 centimeters. Okay, so if I can find the length of OX, okay, then I can also find the length of PX, okay, which in other words is actually the length of QR. Alright, so what I'm going to do is to find the length of OX first, okay, making use of the same right angle. So I have cosine theta, okay, the adjacent side this time round, OX, over the hypotenuse 6. So I have OX equals to 6 cosine theta. Okay, so now I found the length of OX. If I want to find QR, which is also XP, okay, I have QR is equals to 6 minus 6 cosine theta. Okay, remember again, here OP is actually the radius. Okay, therefore it is also 6 centimeters. Okay, and then take out the common factor 6. I have 1 minus cosine theta. Okay, and finally the last part, part B. Okay, they tell you that if theta is equals to pi over 3, calculate the parameter of the shaded region, PQR. Okay, so you can see that pi over 3 here, okay, means that actually your, okay, angle is in the radian mode. So before you calculate, please make sure that your calculator is in the radian mode. Alright, so if you want to find the area PQR, okay, the shaded area PQR, okay, so this part here, okay, I want to find the whole shaded area, okay, the parameter of the shaded area. So I need the length, I need the arc PR, okay, and how do you find PR? Okay, remember the formula, okay, S equals to R theta, okay, S is the arc. So if I want to find parameter, okay, it will then be R theta, okay, plus, okay, PQ as well as QR, which we've already found in A. Okay, so I have to add 6 sine theta. Okay, I also need to add my QR, okay, which is 6, 1 minus cosine theta. Okay, and then after this, I just substitute in the pi over 3. Okay, my radius is 6, so pi over 3 plus 6 sine pi over 3 plus 6, okay, 1 minus cosine pi over 3. Okay, so all these, make sure your calculator is in the radian mode. Okay, after you calculate out, okay, you should get 14.479 to 3 significant figures, 14.5 centimeters. Alright.
Hello everyone, so this is question 19. So let's read the question. In the diagram, AB is the diameter, so this is the diameter of the circle, and the circle has a center O, so here. So actually, once you read this, the immediate reaction should be, this is a right angle, because this is angles in a semicircle. And of course, if you look at the question, they want BAC, so BAC will be BAC, so it's this one. Okay, so once you see right angle triangle, you know this is most likely to be tonkatsu. That is why immediately they put down 8 over 6, because you take this angle, tangent is here over here. After that, what you're doing is you're doing tangent inverse both sides. You can get answer, but take note it's 4 decimal places because they wanted it over here, 4 decimal places. So next, you're supposed to find sector AOC. So AOC is this one, this one, this one, which means sector, right? So sector, we want the pizza. So the whole area is this one. Okay. So to find the whole area, we will need to have this angle, because this tells us how many part of the whole circle is. So to find this angle, our first job is to also realize that actually this and this is the same, because these are both radius of the circle. Once you get the radius, actually you realize that this and this are also the same, because isosceles triangle, and hence you can find this question mark easily. So that's what they are doing here. 180 minus the base angle times 2. Okay, so next thing, once you have this angle, you know what's the proportion. So it's 70 something degrees out of a total 360, because in a circle, the whole circle is 360, and this is only 73 degree out of 360 degrees, so it's a fraction thing. And then they have the pi r square. So in this case, they put r as 5, but there seems to be no other working. So what they did is actually they used the right angle triangle here. So this right angle triangle, and they use Pythagoras theorem. So this square plus together, square root, the whole thing is 10, and hence this radius here is 5. So with that, you get the answer.
Okay, hi everyone. Question 21 is construction question. Okay, where you have an isosceles triangle ABC, where AB and AC are of the same length, and BC is 5 centimeters. Okay, so you want to use a pair of compasses to bisect the angle BAC on the diagram. Okay, so this is angle BAC. I want to cut it exactly into half using a pair of compasses. Okay, so what I'm going to do is to choose a distance that is slightly, okay, just a small distance. Okay, I'm going to draw an arc on this length, AB, and then another arc on the line AC. Okay, without shifting the distance, I'm going to go to this point here. Here I draw an arc in the middle. Likewise for the other side, I draw an arc in the middle. Okay, to draw this angle bisector, I just take my ruler from point A, okay, go through. Okay, so this line here is the angle bisector of BAC. Okay, the next thing, you want to measure the perpendicular height of the triangle from point A to BC. Okay, because this is an isosceles triangle, okay, so the angles here are the same, right? And this line will also cut at 90 degrees. Okay, so you just need to see what is the length of this line that is from A to BC. Okay, I have 2.5 centimeters. Okay, 2.5 centimeters. All right. Okay, going on. Okay, in the space below, it is given that B prime, C prime is 10 centimeters. You want to construct a similar triangle. Okay, so a similar triangle A prime, B prime, C prime, such that the area of triangle A prime, B prime, C prime is 4 times the area of triangle ABC. Okay, so you learn that for similar triangles, okay, when I have A1 over A2, then it's L1 over L2 square, right? Okay, so the ratios of the area is the square of the ratios of the length. Okay, so you can see that you are given that B prime, C prime is 10 centimeters. Okay, the length of BC, originally here you have 5 centimeters. Okay, and if you square it, okay, this is 4. Okay, in other words, okay, this triangle A prime, B prime, C prime, okay, it is 4 times, okay, the area of triangle ABC. Okay, so what you're going to draw for the next triangle at the bottom, okay, I've already given you the length, B prime, C prime, which is 10 centimeters. So the other two lengths that you're going to draw, okay, it's twice in length. Okay, so if this is 10 centimeters, this is 5 centimeters. Okay, whatever the length of AB here, okay, the length of A prime, B prime here is going to be double. Okay, so if you go and measure, this is 3.5 centimeters. Okay, so you need to draw using your compasses. Okay, 7 centimeters and 7 centimeters. So what you're going to do is to take your pair of compasses, open up to 7 centimeters. Okay, open up your compasses to 7 centimeters. Alright, and then at point B prime, okay, draw an arc. Okay, because isosceles, right? You don't need to shave the distance. Go to the other side, point C, and do the same. Alright, so this point here will be A prime. Okay, so you just need to take your ruler and connect the points. Okay, so your triangle is done. Okay, for C part 2, you want to construct a perpendicular bisector. Okay, mark clearly with the letter P the area which is nearer to B prime and C prime, okay, than C prime. Okay, so you're going to compare these 2 points. You want to draw a perpendicular bisector. Okay, so this is the 2 points of reference. This is the line that I want to cut. Okay, so for perpendicular bisector, okay, you choose a distance that is slightly more than half. Okay, so slightly more than half. Okay, and then I'm going to draw an arc at the top of this line, as well as an arc at the bottom of this line, okay, of the line B prime C prime. Okay, and then the same thing, we're going to move to the other side. Draw an arc at the top, and then draw another arc at the bottom. Okay, after that, just connect. Okay, so this line here is the perpendicular bisector of B prime C prime, and you want to indicate the area where it is nearer to B and C. So anywhere along the perpendicular bisector, okay, is exact distance from, okay, B prime and C prime. So if you want somewhere that is nearer to B prime, okay, then the area must be over, okay, near on this side. So if you put it on the other side, then it will be nearer to C prime.
So question 22, in the diagram below, this is the origin here, and A is here, B is here, that's it. And then it says C is a point on x-axis such that AB equal to AC. So actually this is pretty important. So once I read this, I'm going to do this, because it visually tells me that this is a isosceles triangle. And then find the coordinates of C. So C is over here. Actually, the answer is already staring at you, because this is one mark. So if you just draw a line here, this is actually 9, because it comes from the x coordinate. So by the law of common sense, if this is 6, this is 9, difference of 3, then obviously this is going to be plus 3 again. So this is clearly going to be 12. And so it's 12, 0, because it's on the x-axis. So next question, equation of line AC. So AC is over here, and you already have A and you already have C. So you have 2 points. You need to find the equation of a line. This is amateur stuff. So with the 2 points over here, I'm putting it into the gradient formula, -1. And from here is y equal mx plus c. So y equal mx plus c. So what they're doing is they're using the AMS formula. So let me do the EMS version. So we shall start with y equal mx plus c. So this is negative x because the gradient is -1. So -1 times x is negative x. So we're going to choose one point. In this case, I am going to choose 9, 3. I'm going to sub x equal 9, y equal 3. So y is 3, x is 9. And then I solve for c. So c is 12. So in this case, our final answer is y equal to negative x plus 12, which is over here. So for the final part, the length of AB. So let me scroll this up a bit. So you have A here, B here, and again, both of the points you have the coordinate. So this is a straight substitution into the formula, and you'll get the answer straight away. So thank you. Question 23. Okay, we have a circle. Center is O, and then you got ABCD all on the circle. And then AB produced to E. So AB, you draw a bit longer to E. Actually, this also means that this is a straight line. That's another way of saying it. Okay, so 26, 94, 94. I'm assuming, oh no, this is BCE, so it's sorry, CBE, so CBE. Okay, so this is until this line, got to be very clear. Okay, so we want ADC, so this one. Okay, so the first thing you'll notice that actually these A, B, C, D are all on the circumference. So this is again a cyclic quad, which means these two angles are actually opposite angles, and that means these two should be 180. Now this is not very obvious, I know, but like say this and this is more obvious, opposite, but strictly speaking, these two are also opposite. Okay, so after you know that, you realize that if this is a straight line, this is just 180 minus 96 94, which is what they are doing here. And then after that, this and this is 180, so they minus again, and then you get the 96. So next part, we're looking for AOB. So AOB, so that will be the one in the middle. So this will be the one. And once you have this, you know it's very obvious. We're looking for the double V's. So this is the double V that we're talking about. These are two V's, which means that this angle is double of 26. So that's why they have the working here. 26 times 2, you get the one in the middle here, 52. So for the last part, second last part, we want OAB. So let's scroll this up again. OAB. So we want this one. So this triangle is the one we're looking at in blue, and you realize that this OA and this OB are actually the radius of the triangle, which means again this is isosceles. Once you know isosceles, that's why it's base angle, and then you divide. Okay, so for the last part, OBC. So OBC will be OBC. So this is the super small one. So I've colored this in a green color. So if the whole big angle is 86, the small blue one is 64, the green one is just minus away. Yeah, so that's all. Thank you.